IEEE Education Week 2026. This course is AI for technical instructional designers. Faster storyboards, clearer explanations, better learning, by Angelo Athens. Welcome to this short course on using AI to design technical training faster and with greater clarity. Technical instructional design is uniquely challenging because science, engineering, and other content-heavy fields demand diagrams, formulas, tables, and precise explanations that go far beyond soft skills examples most vendors showcase. As the diagram notes, science, engineering, and other content-heavy domains demand diagrams, graphics, tables, formulas, and precise explanations. Today we'll explore how AI helps you navigate that complexity. Technical content is inherently dense, requiring designers to interpret formulas, diagrams, data tables, and complex academic explanations. As the document notes, designers spend enormous time extracting meaning from dense academic papers, SME interviews, and highly technical narratives. This heavy cognitive load often shifts attention away from higher-value work such as strategy, creativity, and learner-centered design. AI helps rebalance that workload. By summarizing dense material, clarifying technical language, and structuring complex information, AI frees designers to focus on the parts of instructional design that require human judgment, storytelling, pedagogy, and learning impact. When instructional designers work with formulas, diagrams, and data tables, cognitive load rises sharply. These elements require simultaneous interpretation of symbols, relationships, and visual structures, which places a heavy mental burden on both designers and learners. The diagram emphasizes that technical content is far more complex than the soft skills examples most schools and seminars teach, highlighting the gap between typical instructional design training and real-world STEM demands. AI helps reduce this load by interpreting dense visuals, summarizing complex explanations, and restructuring information into clearer, more digestible formats. By offloading this cognitive strain, AI enables designers to work more efficiently and focus on higher-value tasks such as pedagogy, narrative flow, and learner experience. By the end of this course, you'll have a clear understanding of how AI strengthens the instructional design process for technical content. You'll learn to identify the core challenges that make STEM-focused training uniquely demanding, from dense diagrams to complex formulas. You'll also practice applying targeted AI prompts to support storyboarding, sequencing, and diagram explanation skills that streamline early-stage design. Most instructional design programs don't prepare designers to work with STEM-heavy material. As the document states, these programs rarely expose learners to dense STEM content, which means new instructional designers often enter the field unprepared for research-driven narratives filled with diagrams, formulas, and technical explanations. This gap creates friction. Designers must decode complex material without the training typically required to do so efficiently. AI helps bridge that gap by interpreting dense text, clarifying technical concepts, and structuring information. AI gives designers a starting point, reducing the time spent deciphering content and increasing the time available for strategy, creativity, and learner-centered design. AI helps bridge that gap by interpreting dense text, clarifying technical concepts, and structuring information. AI gives designers a starting point, reducing the time spent deciphering content and increasing the time available for strategy, creativity, and learner-centered design. AI shines in early-stage design because it handles the heavy lifting that typically slows instructional designers down. It can generate logical flows, propose visuals, and suggest lesson sequences, tasks that normally require significant time and cognitive effort. As the diagram shows, AI can generate logical flowcharts from complicated text, suggest lesson sequences, propose visuals, and craft initial storyboards. By automating these early structural steps, AI accelerates your design process, giving you a strong starting point so you can focus on refining the narrative, ensuring accuracy, and shaping the learner experience. When you paste dense technical text into an AI tool, it can quickly summarize, simplify, or restructure the material, making it far easier to work with. This is especially valuable when dealing with academic journals, research reports, or SME-heavy content that would normally take significant time to decode. The diagram here emphasizes that AI can analyze large volumes of technical material, giving designers a powerful way to break down complexity and extract meaning efficiently. Technical diagrams often require precise interpretation, especially when they include layered visuals, symbolic notation, or multi-step processes. These visuals can be challenging for both designers and learners to decode without additional explanation. AI can help by generating clearer, more accessible explanations for graphs, diagrams, and tables. As the document notes, AI can generate clearer explanations for diagrams and graphs, making complex visuals easier to understand and teach. This capability is invaluable for learner comprehension, allowing designers to transform dense technical visuals into step-by-step learner-friendly explanations that reduce cognitive load and improve clarity. This is invaluable for learner comprehension, allowing designers to transform dense technical visuals into step-by-step learner-friendly explanations that reduce cognitive load and improve clarity. AI can propose visual concepts even when the source content provides little or no visual guidance. This is especially useful in technical training, where designers often receive dense text without accompanying diagrams. AI can generate flowcharts, system diagrams, and conceptual models that help transform abstract or incomplete material into clear, structured visuals. As the document notes, AI can produce examples when source content provides few or none, giving designers a strong starting point for visual communication. By filling these visual gaps, AI accelerates early-stage design and ensures learners receive clearer, more intuitive representations of complex ideas.
AI can help you draft initial storyboards by suggesting structure, sequencing, and transitions. This frees you to focus on creativity and strategy. Artificial intelligence is transforming how we approach storyboarding in instructional design. Instead of starting from a blank page, AI helps us quickly generate a structured draft suggesting scene flow, sequencing, and transitions. This allows us to move faster from idea to visual concept. The process begins with your input, defining the topic, audience, and learning objectives. From there, AI proposes a storyboard framework organizing content into meaningful scenes and guiding the narrative flow. Next, a draft storyboard is created, complete with suggested visuals, narration, and transitions between scenes. But this is where human expertise becomes essential. You refine and personalize the storyboard, adding your voice, creativity, and instructional intent to ensure it resonates with learners. The final result is a clear, engaging learning experience designed for real impact. In short, AI handles the heavy lifting so you can focus on what matters most: strategy, storytelling, and meaningful learning outcomes.
The infographic highlights how AI can support designers with ready-made prompt templates for summarization, diagram explanation, flow generation, and assessment design. These templates ensure consistency and quality across projects, giving designers a reliable structure to start from. They also reduce the time spent reinventing the wheel, allowing instructional designers to focus on higher-value tasks like strategy, clarity, and learner experience. By standardizing common prompt types, AI helps streamline technical content creation and accelerates development. This visual highlights the power of prompt templates for technical content creation, a practical way to make AI more consistent, efficient, and reliable. At the top, the message is clear. Structured prompts improve quality and consistency while reducing the time spent starting from scratch. The diagram breaks this into 4 essential categories. First, summarization prompts, which help distill large volumes of information into concise key points. Instead of manually rewriting dense material, you guide the AI with a clear instruction, such as summarizing a document into 3 main ideas. Second, diagram explanation prompts, which break down complex visuals step by step. This is especially valuable in technical training where clarity, sequence, and accuracy are critical. Third, flow generation prompts, which allow AI to map out processes. By describing a workflow, you can quickly generate structured flowcharts or step sequences that improve organization and save time. Fourth, assessment design prompts, which help you rapidly create quizzes or knowledge checks. With a single prompt, you can generate targeted questions aligned with learning objectives. Together, these templates act as reusable building blocks. Instead of reinventing the wheel, you apply proven structures that streamline your workflow. The takeaway is simple. Well-designed prompts don't just save time, they elevate the quality and impact of technical content. AI can generate quiz questions that align directly with learning objectives, making assessment creation faster and more targeted. Instead of starting from a blank page, educators can quickly produce questions that reinforce exactly what learners need to understand. But AI's value extends beyond question generation. It can also propose grading rubrics, offering clear, consistent criteria for evaluating performance, supporting fairness, transparency, and instructional alignment. Perhaps most powerfully, AI can automate scoring. Tasks that once required hours of manual grading can now be completed in seconds, freeing instructors to focus on feedback, coaching, and deeper learner engagement. In the visual, you see the full cycle: quiz creation, rubric development, and automated scoring, all supported by AI. The result is a faster, more efficient assessment process that maintains quality while reducing workload. AI doesn't replace educators. It amplifies their ability to design meaningful, effective assessments.
AI accelerates technical instructional design by reducing cognitive load, improving clarity, and supporting assessment creation. When designers face formulas, diagrams, and data tables, cognitive load skyrockets. And AI helps interpret, summarize, and structure that complexity. AI strengthens early-stage design. It can generate flowcharts, propose visuals, suggest lesson sequences, and craft draft storyboards, enabling faster development without sacrificing quality. AI improves clarity for learners. It explains diagrams, restructures dense text, and simplifies academic content, making STEM-heavy material more accessible. AI speeds up assessment creation. As we noted in this webinar, AI can recommend quiz questions aligned with learning objectives, propose grading rubrics, and automate scoring. But human expertise remains essential. AI frees designers to focus on strategy, storytelling, and learning impact. The designer's judgment, creativity, and contextual understanding are irreplaceable. Use AI as a partner, not a replacement. The most effective workflow blends AI's speed and structure with the instructional designer's insight, experience, and pedagogical intent. Great job! You have completed AI for Technical Instructional Designers.